Here we go with session 4 of day 1 of the 2025 Technical Symposium. Again, I'm Paul Green. I run a biogas advisory business and I drive the biogas.tv website. In this session, we're going to hear from Paques about digesters that are used in settings that are for sand-laden manure or heavy grit type of scenarios. You can ask questions on the fly in the chat or the Q&A box, and we'll spend a few minutes on questions at the end. Later today, you'll get an email from me pointing to the slides from this talk on my website. A video of this presentation will be available at the biogas.tv website by the end of the week. With that, I'd like to introduce Timur Dunayev. Timur is the managing director and CEO of Paques in North America. With close to 20 years background in process engineering, specifically in anaerobic digestion, Timur is now focused on growing Paques in North America for both the wastewater and RNG sectors. So with that, Timur, the floor is yours.
Thank you so much, as always, Paul. Very happy to be part of these. I love the format, love the lineup. Always makes perfect sense to me. I am indeed treating this as day 1, day 2. Today, I'll spend a tiny extra time on introducing who we are, a little bit more than I'll do tomorrow. So hopefully, same group of people rejoin, so I don't need to regurgitate the slides. Today, I'll be talking about our specifically developed technology, or the set of opportunities is the way how I look at it, to address a very specific issue of either sand-laden manure or overall high-grit environments. But to kick it off, first of all, who we are. Paques has been around for a very, very long time. Actually, we've been in continuous business operations since the 70s, starting in Europe and in North America since early 90s as well. As of 2013-2018, which was the period of acquisition, we're now not a privately owned company, but rather owned by Ski on Water, which is a group of companies that now more than 14 portfolio companies generating more than 1.5 billion euros in revenue per year. Those are the last figures from last year, so very, very fresh. And it's good to be part of a group that is specifically oriented towards water, wastewater, and renewables business. Here is the portfolio companies, and Paques is shown right here in Friesland in the Netherlands, but that's where the headquarters and the original business was started, and this is more of a Paques-specific map. And obviously, we're talking about this business unit right here. I call it C2C, Caribbean to Canada, because that's the basic territory that we cover as Paques North America. And in Paques North America, we are a fully functional, separate business unit with full project execution capabilities across the entirety of our region, including procurement, project engineering, management, commissioning, startup, and everything related to EP project execution. As I said, the historical development of the technologies is right here on the slide, and today we're going to be concentrating very specifically on this one. The very first technology was introduced to market in 2017. By this time, we have over more than a dozen installations across the world, and I'll be presenting more numbers on that. Some good slides to see when the presentation is going to be sent, but I want to concentrate on the technology itself. So CBD is specifically designed as a completely stirred reactor with an addition of, and I already threw that word around, the addition of a few opportunities that I'll be talking about that are uniquely designed to continuously address any accumulation, or it's better to say prevention of accumulation of heavy solids within the vessel. So let's chat about how we're going to do it. The problem statement for this technology, the way I see it in North America, is high grit or sand laden, or let's say earth laden substrates. And that could, in this specific case, I'm showing a sand bedded manure, but actually for a lot of food digesters, the grit is also a big problem, right? It depends on how much you bring together with the source. This is one of the most stark examples that you see on your screens, and that's why I like to use it. And so the problem statement is this: if you pre-treat any amount of sand, or let's say any amount of grit preliminarily, you'll definitely be losing some of the volatile solids, because it's fully impossible to separate grit and or sand with 100% efficiency. And while that is also the case for our technology, the main difference is that the separation happens post-digestion or during the digestion and not prior to digestion, which is the important part here. And as you know in your calculations, that additional 5 to 10% VS loss that could happen if you pre-treat your substrate are quite an important addition to the biogas generated, especially for RNG facilities. So let's talk about the meat and potatoes of the things. The basic idea is that we have a completely stirred reactor where we create a continuous downward flow for the purposes of mixing. And that's quite a high specific energy put into the system for mixing. And doing that, we accomplish a few things, right? The thing number one, and there will be a separate slide on that as well, we're continuously beating down for any formation of the scum layer on the top. And for all of you that have operated digesters, you know that formation of scum, especially for high solid substrates, could be quite a problematic situation if you build up a scum layer on the top and you do not continuously mix it in. And so the continuous recirculation of mixing creates the beat down effect on potential scum formation. Together with that, we're inducing an additional downward flow within the reactor in order to aid gravity, right, in selective precipitation of or sedimentation of heavy solids, right? Because they either precipitate there and form there, or they're introduced together with the substrate. Once they make their way to the bottom, both together with gravity and with a forced induced flow, there's a hydraulic scraper that is continuously moving on the bottom of the reactor, with the entirety of the operation situated on the outside of the vessel. So there is no driving parts on the inside. There is only an isolated, fully sealed gearbox. And then we gently push on a continuous basis all the potential heavy formations on the bottom of the system into precast concrete holes on the bottom of the reactor, where they're continuously extracted and circulated around a hydrocyclone. So what that allows us to do is to continuously drive the solids towards the hydrocyclone with quite a high recirculation flow. And the cyclone is continuously removing the solids. And so what you accomplish is selective removal of solids with some level of digestate. Actually, the last slide on this presentation is going to be of that, where you are selectively removing those solids from the bottom and you prevent any potential accumulation within the digester, right? But that is all done on a continuous basis. To give a couple rule of thumb numbers that I like to throw around. Assume rule of thumb SRT of 25 days within this digester. So our aim is to turn it around approximately twice a day. So any inert particle that enters into the system will have been passed through hydrocyclone at least 50 times for the potential of removing that particle from the system. And this high recirculation flow allows us also to feed into that scouring flow for everyone who's tried to move high solids substrates. You also know that moving them on semi-regular basis can create plug-in problems and things like this. And here, since we have a high continuous recirculation flow, you can even intermittently feed into this line in order to combine it together with the feed, not create any stagnant zones, pre-mix it before it's getting fed into the digester. And also a high separate recirculation flow has a room for the installation of the heat exchangers if needs be. And that's quite an effective way of temperature control as well. So the reason why I said opportunities is because in the end, this is an above ground tank. If you look at it without anything, and what we're trying to do, we're trying to introduce engineered opportunities in order to mitigate a very specific issue. And so this is some CFD that was done for the mixing, and we have evaluated different methods of mixing. And what we're trying to highlight here with our flow is what the zones, the separate zones. So the high danger zone of scum formation receives really high mixing capacity, right? And then as it passes through the middle zone is, let's say, a more of a quiescent zone. And in fact, when we're trying to take the effluent out, I'll go to the previous slide, you will see that we try to take it out, let's say 1/3 above the bottom of the reactor. And then on the bottom, you have an additional stirring together with this. So all the dead zones with the usual accumulation are addressed using this plug flow mixing method. And so I'm making this distinction because when I model this, and let's say in purely technical chemical engineering terms, this is a CSTR, but the mixing method is modeled as a plug flow mixing for this specific system. And so I think a picture is worth a million words, 1,000 words, right? So this is the a middle cut of our CBD system. What you will see is this precast concrete holes, and basically usually what we use in North America is bolted coated steel tanks, right? And so you can install a BSR, base ring, into the system, and the concrete, and especially for people in agriculture, every single silo that you've ever seen has the same precast concrete holes on the bottom, right? Well, not the holes, the pull-through channels. And then what you see here are recirculation pumps and the drive mechanism for this for the rake that continuously moves on the bottom. And what you will see is that rake, this is the precast drive into it. The only gearbox is there, and the gearbox is completely isolated from the environment of the digester. And then we recirculate and we create quadrants of mixing with angled nozzles on the top of the reactor for the continuous inducing of both downward spiral flow and then beating down of the scum layer. Over 18, I think I said 14 in the beginning, forgive me for that, over 18 installations, food, pharmaceutical, fermentation, agricultural, manure, and distilleries business. And once again, the highlight and the point of engagement with the system is high grit or high potential precipitation formation. The reason why distilleries are highlighted is if you've done, let's say, corn to ethanol stillage, you know that it has high calcium, high magnesium, high phosphorus, high nitrogen. So you form calcium phosphates true-wide in those environments. And so that's also a very good candidate for CBD. So we have no pretreatment requirement there. Simple operation, great mixing, no mechanical mixing, no short circuiting, and no scum formation. And those are the advantages of the CBD system. This is an installation. I've already spoken about sand lane and manure, right? You can see this old sand lane in this installation where they've started to move away from using the sand lane. The reason why I like to highlight these data is not to spend too much time on the specific treatment, though the treatment itself is quite good for manure digestion. You will see we're right around 65% VS destruction, right, measured as COD in this particular case. But also what's important for me to highlight is how long these data periods are, right? I'm not showing you a snippet of 1 day of operation. This has been in a continuous operation for quite a long time.
Timmer, we had the perfect question come in.
Yes, please.
How do we prevent those bottom holes from plugging?
That's an excellent question. I'll go back to the bottom. Some of you have spoken to me. I'm a big proponent of not promising I call it pinky dust or fairy dust and no magic ones. Indeed, the bottom holes have a high potential for creating the precipitation, and we're not dealing with that by ignoring it. So what we've done is there is quite a few mechanical additions to the system, and obviously this is not a PNID. And if anyone wants to go in depth, I can show the potential PNIDs as well. So there's a few things. Thing number one, first of all, we have quite a high hydrostatic pressure. The minimum height here is 65 feet, right? And the entirety of the hydrostatic pressure is pushing on this. So these holes are not just a shallow flow. This is high hydrostatic pressure with high potential to push things through. That's number one. Number two, high recirculation velocity. Here's another rule of thumb for anyone who's taking notes. Let's say for 2.5 million gallon digester, the recirculation flow rate is going to be around 4,000 GPM. So we're creating high scouring velocity in those channels as well, right? So we're making sure that it's way more than 3 meters per second, which prevents any particles of accumulating there. So that's number two. Number three, every single pipe connection has both the flush nozzles and the pigging nozzles, right? Well, ratting or pigging, depending on what side of the world you're from. I think in the US we use pigging, right? So there's blind flame connections on the T's in order for you to one inject high nitrogen or high water flow if you need to flush it through under certain requirements. And if you start accumulating solids, what you can do is there is a blind flange on the T on the section of those pipe that you can send a pig through if you need to clean the channels a little bit.
Good. Thank you.
Good question, by the way. I love that question. Another installation pharmaceutical, just another cool photo with a very long information, but I think I'll highlight this one. I think most of the people in RNG industry have heard about this project, quite a prominent one. We're glad to be part of this. This is a Greencrete project in Worcester for Greencrete. They're a company that created the whole treatment schematic, but the anaerobic digesters and biogas desulfurization at this facility were provided by Paques, and the digesters are CBDs, right? So what I like to highlight here, first of all, obviously, it's always cool to show big installations. It's a really nice 12-tank installation, but the reason why I like this photo, besides obvious awesome factor of large installation, is on this photo right here, you see the external drive sitting outside of the system, right? And besides the piping for recirculation, right? And the biogas collection piping, there is literally nothing else on the walls of the digester or supported there, right? And if anyone has ever operated side entry mixers or anything of the sorts, you know why I'm highlighting this. A cool thing to highlight, we have a pilot going on in South Dakota right now, and I think I'm coming up on my time anyways. And so the reason why I wanted to install these photos, I can't talk too much about the pilot yet, though I think at some point we will. The cool thing to highlight it here, and this is our design specific for this industry, hydrocyclone. I actually don't like calling them hydrocyclone. I think people are used to hydrocyclone being small off-shelf items. These are specifically designed for these specific applications. They're large whirlpools, what we call them. And what you can see here is recirculating the digester contents or even manure, pre-treating manure a little bit before the digestion. And so what you can see is once it's recirculated around, what comes on the bottom, you will see the dryness and the material separated there, right? And I think it's quite clear. And you can see the accumulation of how many solids were separated. That's one of the dumps that happened. And so what's highlighted here is preferential separation of coarse solids without losing a lot of volatile solids at that. We're at 19 minutes, Paul. I think that was the call, right? 19 minutes.
Yeah, I think so as well. Question came in, what volume of the reactor is gas that is held up by lack of mixing? I read this a
I
couple times to
I
myself, but
I'm
I'm
not
not fully sure
I'm not fully sure what the question
I
means.
get it.
Volume of the reactor that's held up by improper mixing.
Yeah,
I don't know what that means. I'll
yeah.
respond to what's on top of my mind. Might be completely off, but please feel free to drop a message clarifying.
So
Uh,
here we go. Here we go. Another way to ask, what is the specific gravity of the manure?
the specific gravity of digestate is between 1 to 1.1, usually on the lower end towards 1. So after it's digested, the specific gravity of manure itself is not that different from water, but the heavy particulates can have specific gravity anywhere from 1.6 to 2.6 to 2.9, depending on the materials. And that's why hydrocyclone particle size distribution is also very important. Much finer particles, even at higher specific gravity, are not nearly as easy to separate. But at higher specific gravities, that's what we're trying to separate with hydrocyclone and the specific forces.
Hopefully that helps to the questioner. Yeah, so we're good on time. Getting some feedback that it's a very cool design, Timmer. So you got that going for you.
I,
Um,
uh, I love it. I'm also a big fan. Whoever said that, so let's fan out together.
let's see. What is the lowest diameter of the sand fraction can you separate with your system? US
Um,
sieve number or size?
yeah, 0.25 microns is what I've been using for a very long time. Don't ask me specifically to present tremendous amount of data on that. That's one of the things that we're trying to determine with specific testing. Uh, for the sites that we've examined, I would say 0.25 is quite a good cutoff point because that represents more than 70%. It more than 70% is above that, and that should be more easier separated. And my argument is that at the finer size, if it even if it's not separated, it stays in the digestate matrix and comes out anyway. So it does not
Yeah.
create the problem of creating the sedimentation layer on the bottom. But that
Oh,
number right now is not, I wouldn't call it a Bible. That's sort of like an engineering rule of thumb right now.
yeah. A term here I'm not familiar with. What is the MTBF? M,
MTBF.
M is in Mary. Okay,
I'm
I
also
don't know.
not
Mean
familiar.
time between something, maybe the questioner can clarify the
Yeah.
question. Can it get overloaded due to failures and power loss?
Yes. Yes, indeed, power losses is probably the biggest argument right now because for controlled shutdowns, we recommend continue running the rake, right? If you need to control shut down the pumps, and then you add periodic water flush cycles. If we lose the power continuously for a week, there will be a restart sequence. What is the difference between 24 hours and a week? That we need to determine on case by case basis. If the shutdown is anything less than 12 hours, I don't see a tremendous problem occurring. I would still be careful with the restart up. And I'll highlight why I'm saying that. Because if the feed is not there, your CSTR should already be relatively clean on a continuous basis if you continuously run the system, right? So if you stop the feed together with stopping the system, the only thing you need to worry about is not overexerting the torque on the rake on the bottom, right? If anything heavier accumulated, and then just restarting the pump so there is a proper flow.
So a question came in that the South Dakota unit being a pilot unit, what does a full-size unit look like in size? And you were touching on that with some of those installation pictures you showed, but some of them have the whirlpool next to it. So I'm not sure if the
Some of
nature of
them
the
don't.
question is the digesters or the whirlpool or, yeah.
Yeah, so the Whirlpool pilot is a full-size pilot. So this Whirlpool is a full-size Whirlpool for the application that is being used.
Yeah.
And we can build them slightly smaller. That's on the smaller size of the full size. We can get them relatively bigger, up to let's say 75% larger for the larger installations, but this one is good anywhere from 1.5 to 2.5 million gallon digester.
Okay. So I think I could present the answer to this, but I'll let you do it. How do you address digester cleanout?
Digester cleanout. The whole idea is not to have to clean out the
There is
digester.
no cleanout, right?
There is no cleanout. The whole idea is that you continuously preferentially move heavy solids to the bottom of this hydrocyclone and preferentially remove them in this form from your system, so you don't need to shut down your digester for the cleanout.
Yeah. How is heating accomplished?
Yeah, so heating could be accomplished many different ways. I am relatively agnostic on it mechanically, but a large recirculation flow allows us to install heat exchangers right here. If you're asking me for my specific preferences, are shell and tube or spiral heaters, heat exchangers is what we
Yeah.
use.
Thank you. So we got clarification on what MTBF is, mean time between failure.
Mean time between failure. Right now, we've operated the systems anywhere from 18 months to 7 years without any stoppages. And the 18 months was the stoppage was to replace a drive on the outside. And after that stoppage, we changed the drives to the new drives that are now running and haven't had stoppages. So that's the answer that I have right now. And the system on the first photo of installation has not had stoppage in 7 years. So this installation has not had a single stoppage besides usual O&M on moving parts in 7 years.
Cool. Okay. Is the feed batch or continuous?
Could be both. I prefer continuous, but having continuous recirculation flow around allows us to, let me go back to that PDF. Continuous recirculation flow allows us to push into this recirculation flow, which allows us a little extra room for semi-batch feeding. I would still be concerned about clean out in between the feeds, even on the short feed line.
Is there maintenance required on the gearbox within the tank?
No, there is no technical maintenance required. The lifetime should be 15 to 25 years on the gearbox because the oil and the compressor line are all precast and sit on the outside. We have not had a single failure of the gearbox specifically to date. Is it possible? Yeah, mechanical failure is possible.
What is the typical turnover time of the digester, volume divided by recirculation flow?
Twice a day.
Is a macerator required?
Macerator would be required, especially depending on the feed and what comes out as a straw. We do prefer macerating to be below 4 millimeter in size. That is correct.
Well, that was a flurry of questions. Thank you for your engagement, audience. Any other last questions before we wrap this? Again, these slides will be on my website tonight. Timmer sits in Philly and is highly responsive, highly available if you would like to check this out. So we were originally thinking, sand-laden dairy farm manure, but getting a lot of phone calls about feedlots. Seems like people are looking at beef feedlots and a lot of grit in feedlots. So we're starting to play in that space.
I will throw the food digesters where they use scraping to pick up food as well, because the amount of dirt that ends up getting there and the amount of grit that also ends up getting there is quite substantial. So I do not discard that place either.
So we've had some questions about you can do the CBD approach in the full 25-day digester, or would there be any benefit to do a short CBD cycle in a hydrolysis tank and then just go to a conventional digester after that? Is that worth looking at?
I think if I had a crystal ball into the future, I think that's where we had it. The challenge with that approach is providing empirical data. Everyone loves empirical data. And so my challenge is, and I'm not going to steal too much time, but if anyone wants to talk it through, I'm available. The challenge is, let's say, addressing variable levels in pre-acidification tank, right? Addressing HRT, hydrogen formation, specific material selection on depending on the formation of VFAs and stuff like that. None of them are insurmountable. My thing is, I can present full scale data on manure digester on the full SRT. We have not been able to yet present the data on pre-acidification tank, but my crystal ball is looking in the same direction.
Yeah, yeah. Okay, thanks, Timur. Great product. We will adjourn the high grit, high solids part of this presentation. And sorry for any confusion about the agenda. We've got Bernie Chef coming at the top of the hour. We're going to talk about digester operations. So we're adjourned.
Thank you.
Thanks, Timur.
Thanks, Paul, as always.